All right, testing, testing.
Test.
Can everybody hear me? All right. Welcome to the best room of the day, the electric vehicles room. All right, we're going to start quickly with some safety. So just so you guys know, there are 3 doors. There are 3 exits that you guys can exit out of. So we have to go back through the main doors if we need to exit. There's going to be doors directly in front of you, to the right and to the left. The ones on the left are the most important because that's our evacuation route. So if we need to evacuate, we'll go out, we'll go to the left. And you're going to go all the way down the drive that you came in on, past the fountain, all the way out to where the kind of driveway hits the main road. And that's where we'll gather if we need to evacuate this room. What was the question? Sorry, I didn't hear the question. Oh, no, we will not be. But in case of an emergency, that is the way to exit the facility. Okay, so this is the electric vehicle room. We have 3 sessions here. The first session is going to be focused on timely interconnection of residential customers. Our second session will be focused on DC fast charging and fleets. And our third session will be focused on vehicle grid integration. My name is Lydia Krefta. I'm the Director of Clean Energy Transportation at PG&E. Our team's responsible for our transportation electrification programs, everything from providing incentives for EV fleets to deploying vehicle grid integration pilots to providing rebates for customers who are looking to purchase pre-owned electric vehicles. So kind of a wide range of portfolio. And I'm joined here today with, clicker, where'd it go?
Oh, I got it. You're good.
Perfect. I'm joined here today with Brandon Jasmine. He's our supervisor for residential focused EV programs. Tina Sterling, who's our manager of service planning and design, our Express Connections team. And then Chris Rhodes, who's our supervisor of service planning and design, the Express Connections team. And like Quinn said, we're going to talk to you a little bit about some of the different challenges that we're facing in deploying electric vehicle technology, and really encourage you all to ask clarifying questions. If you have other challenges that we should be thinking about, please let us know. This is meant to be kind of an open discussion with you all, just to really dig into the problem statements so that we can think about ways to develop some solutions to solve these different problem statements. Thank you. Okay, so before we kind of jump into the specific residential focus, I'll just ground everybody on some of our goals. So I think, as everybody probably knows, the state of California has a goal to have 100% zero emission vehicle sales in 2035 for light duty vehicles, and 100% of medium and heavy duty vehicles to be zero emissions vehicles in operations by 2045. And so in order to help the state reach those goals, PG&E has set some goals of our own. Our goal is to connect 3 million electric vehicles to our system by 2030, and that's both residential and non-residential light, medium, and heavy duty vehicles, and also to enable at least 2 million of those vehicles to participate in vehicle grid integration applications. And that's a mouthful. That means basically anything that alters the time of an electric vehicle charge. So that's anything from vehicles responding to passive time of use pricing, all the way up to active managed charging, and even bidirectional charging to support the home and to support the grid. So those kind of broadly are our goals for this session. We're going to dive into that 3 million electric vehicle goal, specifically the residential portion of that goal. And I'm going to hand it over to Brandon to talk a little bit more about residential EVs.
Okay, so thanks for that introduction, Lydia. So when PG&E meets its True North strategy goals, we know that it'll drive the need for significant investment in our grid and supporting infrastructure. And as you can see up on the screen, PG&E has seen significant EV adoption across its service area, with more than 400,000 EVs. That means that 1 in 7 EVs across the nation is supported by PG&E's grid. It's also interesting to note that the CEC estimates that 1.2 million EV chargers are needed to help support that growth by 2030 across the state. That's a 93% increase compared to where we are today. So the last thing that I'll say about this slide, and I'll leave you with, is that growing EV adoption is expected to represent an unprecedented 70% growth in our electric load over the next 20 years. So if we go to the next slide, what does that mean for our residential customers? Well, Across PG&E, for our single family and multifamily connections, PG&E is looking for ways to connect customers more quickly and more cost effectively. So that means trying to avoid unnecessary upgrades, also realigning rebates and incentives, and lastly, creating better visibility for our customers to see system constraints that may exist. We know that ensuring affordable and timely connections for every single resident in our service area is hugely important. Will have impacts on their daily lives. It'll also help them on their journey to decarbonizing and accelerate EV adoption, putting us one step closer to achieving our climate goals. So if we go to the next slide, if we take a closer look at what that means for single family connections, we have the customer perspective, and we also have the utility perspective. For the customer, it's all about enabling better customer visibility into the needed upgrades and also the local connections and the constraints that are in those systems. For PG&E and the utility, it's about enhancing visibility into the customer connections and also the evolving capacity of our transformers. So I know that provides a little bit of an overview, but we have Chris and Tina who are going to provide a little bit more context from what they see on their day-to-day interactions with our customers.
Awesome, thank you. Well, good afternoon, everyone. I am so thrilled to be here today, and I hope you are too, because we are all part of making the world better. And through your brainstorming, innovative thinking, we're going to get there. So what I wanted to share with you is a little bit about our team and our organization, Service Planning and Design. Just in 2022, we had 73,000 applications coming through our services for us to process for both residential and commercial. This year alone, we're already at 67,000 applications coming in for us to process. Of that 67,000, 40% we've seen residential influx applications come through for what? Solar install, electric vehicles, battery charging, and then electrifying their ADUs. It helps offset some of their costs. So with that being said, it's a challenge because the amount of volume that we're seeing that is coming in through our system, you've heard Elon and others speak to 3 times, energy is coming into our environment. That load is critical and we need to get ahead of it. And how do we get ahead of that? Is with you all. Your brain thinking, your brainstorm thinking, out of the box, innovative ideas to help us identify controls on the customer side so the customers can really see what their load looks like, because in today's world, customers really don't know. They really believe that putting solar in their home and installing electric and batteries, that they're actually saving energy, but they're using more energy. So there's that frustration on the customer side. They don't quite understand the load at their current home. And then on PG&E side of the house, when customers are trying to apply for services, it increases the demand on our circuits, right? Impacts our capacities, and therefore it puts strain on our distribution and transmission lines. So unfortunately, in many cases, customers cannot connect their services in a timely fashion that's cost effective for them. So sometimes they'll change their mind. So that's our challenge today. We're seeking your guys' support to help us identify amazing controls that can really identify the challenges that we're faced today. And then Chris is going to share some of the challenges that we're seeing on the side of PG&E side of the house in a little more depth.
Thank you, Tina. As you can imagine, all of these customers that are coming on with electric vehicles now, they go through several different routes. And the customers that face the highest challenges also present the greatest challenges to PG&E. It's symbiotic, okay? And what that means is the volume of applications that go through the most difficult process to get through also impact PG&E's resources the most, okay? So we're looking to try and serve those customers in a more efficient and expeditious manner, which doesn't just help them by processing their applications faster and cheaper, which is just as important, but also it impacts all the rest of our customers less as well, because every single extra design that we do adds to the backlog of designs that we have. Every single construction job that we have adds to the backlog and list of construction that we need to complete. And all of those basically end up impacting our rate base and pushing up our rates. So the more we can do in a more simplified fashion benefits not just the electric vehicle customers, but all of the customers for new business and PG&E.
Great. Well, thank you for that, Tina and Chris. So hopefully that provides the audience with a little bit more clarity of what our single-family connections are dealing with. When we think about our multifamily connections, think about our equity customers who want to make the switch to an EV, but they can't because they don't have access to EV charging at their multi-unit dwelling or wherever it is that they live. How do we get those customers the needed infrastructure they need to be able to charge at these locations without having to do significant costly upgrades at the expense and the time of the property owner? So I think that's one of the challenges that we see with this segment. And it's interesting to note that more than 80% of those that have adopted EVs are in single-family homes. So with that being said, what we have on the bottom part of this slide is some of the challenges that we see with those multifamily connections. First, think about the shared infrastructure at a multi-unit dwelling. Think about a 4-unit apartment. Typically, if the tenant is lucky, they'll have a dedicated parking spot, and they may not at all. But if that property owner is open to providing the necessary infrastructure, that property owner has to make a number of tough decisions, right? They have to think about what's involved with getting those chargers installed. Do they provide a one-to-one charger for every parking spot? Or does the infrastructure require that they have to give up one of those parking spaces to make up for the variances that come with the infrastructure? That's not an easy decision to make. In addition to that, we know that from a property owner's perspective, the return on investment at these lower utilization sites is really challenging. And then you think about it, in addition to that, does the property owner then need to also become the administrator for billing? Do they have to manage the ongoing O&M to help support that infrastructure? And lastly, how do we better align the necessary rebates and incentives to reach our customers and also our property owners? So across single-family connections and multifamily connections, we recognize that there are significant challenges to helping our customers on their path to decarbonization. But PG&E is making efforts to bring down those barriers with its existing incentives and rebate programs. In June, we launched our multifamily housing, small business EV charging program that helps those that qualify to get access to level 1 and level 2 chargers and additional support. In the future, we hope to launch our residential charging solutions, which will also provide the necessary engineering, technology, and information, and the supporting infrastructure without having to get those necessary system upgrades to smart panels. So despite all of this stuff that we're doing at the company, we recognize that there's still much that needs to be done in order to help us meet our goals, which is why we're excited to speak with all of you. So I'll kick it back over to Lydia.
Thanks, Brandon. So, okay, this is the time where we start to get some clarifying questions from you all, other ideas, things that we missed. But just before we jump into that, I think just to kind of like pull everything together that you all just heard. So you saw Brandon share the numbers that we're at like 450-ish thousand EVs connected to our grid at the end of 2022. Our goal is to get to 3 million, and the vast majority of those are residential, like light-duty vehicles. And so our goal is basically to like 6x what we're seeing. That's the right math, right? Yeah, 6x what we're seeing. In the next 7 years, like that's a lot. That's a change, a complete change in the way that we've seen kind of business occur in the past, right? And so we know we need to do things differently. We know there are challenges that we face in order to get these electric vehicles connected and connected quickly in a cost-effective manner. And so that's the problem statement we're putting out to you all. And really interested to hear your questions, your thoughts, your ideas, to see how we can kind of work together to meet these, I think, really ambitious but necessary goals that we have. So we're going to do just quick logistics. So questions in the room, and we've got some questions online, I think. So Brian has a mic that he can walk around. Just raise your hand if you have a question. We'll start with the room, and we'll kind of bounce back and forth between the room and questions online. And it looks like we've got one over here to start. And maybe just state your name, affiliation, and then your question.
Mehdi Ganji, I am with ENAMP. It's a technology to bypass the electric meter upgrade. We know that in the state of California, we have about 8 million homes that were built before 1990s, which require the meter upgrade. If I'm not wrong, the number of those customers in SCE network is about 3.3 million. Do you guys have any idea of how many homes that you have in your system that requires a meter upgrade, and if there is any sort of way to define or find out those homes that require a meter upgrade?
Do you guys have any information on that?
So what I can share with you is that's why we're here today. We don't know what that true load looks like on the meter, on where customers need to upgrade their panel. That's the type of controls and IT technology that we really need for a company to be able to forward think, proactively look at where those load pockets are in our system, where customers may need to have a panel upgraded, and be able to eliminate that need to upgrade that panel. Because knowing that we have a 70% growth over the next 20 years, there's no way we're gonna be able to keep up with that volume of panels that require upgrading. In today's world right now, we're struggling to keep up with it. You're welcome.
All right, we got down in the front right here.
For both the single-family and multifamily use cases, one of the challenges of behind-the-meter stuff has always been, can utilities fund that within their regulatory structure, and who pays, right? And multifamily, even more complexity around that. Do you guys have any thoughts around that, and what might be allowed within your regulatory constructs?
Yeah, that's a good clarifying constraint, maybe, question. So the state of California is moving to the transportation electrification framework, which is basically like a single statewide program that would provide rebates across all the IOUs territories. Multi-unit dwellings or multifamily housing is one segment that the TEF will basically provide rebates for. So utilities will be able to support incentives for multi-unit dwellings in addition to fleets through the transportation electrification framework. There's also a couple of other mechanisms that we can leverage to work on some of this, and one in particular is the low carbon fuel standard. So we're allowed to hold back a certain percentage of the low carbon fuel standard credits that we generate each year, and then leverage those to develop programs. And so Brandon talked about two programs, residential charging solutions, and our mouthful multifamily and small business charging charging program. Both of those are funded by the low carbon fuel standard. So there are mechanisms to do it, somewhat varying. I think we had another question right here. Oh, and then we'll go to the phone after this one.
Liang Min, Stanford University. So these three areas are great: residential, DC fast charging, and also the bi-direction. And my question is PG&E has any initiative to encourage daytime public accessible level 2 chargers, for instance, on the corporate campus, parking lots, grocery store, etc.? Because we did a study last year, and on the nature energy, the key results outcome is for the California, for the 2030, to support the electrification futures, we need way more public accessible level 2 chargers during daytime. We should charge a car during daytime when sun is shining.
Yeah, so we deployed about close to 5,000 chargers through a program we called the EV Charge Network that was focused on multifamily housing and workplace. With the shift to the transportation electrification framework, I think there will be continued opportunity to provide some of those incentives through the utilities, through the state. It'll be focused on a wide array of things, not specifically like workplace or public charging. I think a multitude of level 2 charging, and then fleet charging, basically. So there's, I think, still opportunities to do that, but I think there's a lot of open space to innovate in that area. that I would encourage folks to think about as we're thinking through different solutions. How can we encourage that, both the charging and then like customers being incentivized to charge during that period of time. The other thing that we do have is our electric vehicle rates. And so we encourage charging on our electric vehicle rates between 12 p.m. or 12 a.m. and 3 p.m. So I think there's a lot of opportunity in kind of thinking about how like different pricing signals, right, to also encourage some of that. So both on the infrastructure side and the pricing side. So great call out of a challenge to think about. So let's go to folks on the live stream. Do we have any questions?
Hi there. Yes, we have 342 attendees joining us remotely. Wow. And I will read off the first question. We have about 20 questions or so. I know we might not get through all of them. This one has the most votes. Here we go. Are there any hardware standards that enable external control signals over real-time capacity limits in consumer charging devices?
I'm not aware of any of those items that are available currently.
Yeah, me either.
Are there any standards that enable, can you read that one out again?
Are there any hardware standards that enable external control signals over real-time capacity limits in consumer charging devices?
Okay.
We might want to throw that one up to planning and come back with that answer after the call.
Mm-hmm. Yeah.
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 I don't want to talk out of turn. I don't know if there are standards. I do think that is an opportunity, but I do think, yeah, we can jot that question down and make sure, was there a mechanism to like provide feedback? Does anybody know who's helping to plan? We'll take that question down.
Yeah, we'll definitely take that one down.
And figure out how to respond to it. And let's do one more on
online,
the live stream.
One more question from online. With 6 votes, how much of EV integration is bidirectional right now?
We connected our second home. Woo! Just last week. So not a lot, and so that's why that's an awesome opportunity for folks to help us figure out how to better do that cost effectively and more seamlessly in a way that limits the impact on the grid. So great question. All right, there's a couple more.
A lot more.
Let's go over here.
I'm going to pause you just so folks on the line can hear. Yeah, you might need to flip on the mic if it's not on.
Testing.
There it goes.
Hey guys. Mark Rawson with Rhythmos. Question on how do you currently detect EVs on your system other than them going through like interconnection? I mean, what is your plan for being able to look out into your system and identify new EVs coming on that maybe aren't going through the planning process?
Yeah, do you guys want to talk a little bit about like the EV rate notification process, and I
Yeah.
can talk a little bit about some of the other things we're working through?
Yes, I'll take that one. We do hear about the ones where they need to upgrade their equipment or they need infrastructure improvements. They come through as applications. But also customers may generally tell us that they need to do a rate change to take advantage of better rates for electric vehicles. And those ones come through our call centers, and applications are generated through that, and we take that into consideration and do calculations to make sure that we have the grid capacity for that.
I'd say it's also definitely an opportunity. So I think we have, what did I say, 450,000 customers at the end of 2022. We've got about 100,000 on our EV rates. So that leaves a pretty sizable gap of like identifying other EV customers. We have done some work with WeaveGrid, actually, who's in the room, to provide us with some AMI data to help us identify some EV drivers. We've done some internal modeling to try to understand that, but we run into some challenges when there's a customer who has EV and solar. And so that's like a very large percentage of EV customers right now. So it takes a big chunk of folks out of there. So I think one of the things that we know would be very valuable in meeting a lot of these challenges is understanding where every single person on our grid who has an EV, like where that's located at like a point specific, address specific point. Yes, you've had your hand up for a while. Oh no.
Is it on?
Yeah,
There we go. Yeah.
It's Richard Coe from the Public Advocate's Office. We've been doing a project to model the spatial distribution of EVs across the grid in California to understand the impacts, what upgrades are being needed. I guess I'm interested to hear from you guys as to what sort of work you guys are doing to understand this is the forecast, so kind of the companion to the last question, how you're forecasting where EVs are going to be located spatially across your network.
Yeah, so a couple of years ago, we developed a tool called our geospatial tool. And basically what we have built into that tool are 3 different forecasts. Residential EV adoption propensity, where we think there will be charging on corridors like DC fast charging, and then medium and heavy duty fleet charging, kind of where we expect areas where there's like a lot of like warehouse facilities, right? Or a lot of where we have the information understanding of vehicles today that we know are going to have to transition because of advanced clean fleets. So we have a couple different scenarios. We layer that all together and we feed it directly into our distribution planning process to then kind of overlay it with our current grid conditions, our current grid plans. I think there's like tons and tons of opportunity to get more granular data. This is probably next topic, but one thing that we're really interested in is like long-term fleet planning and understanding where vehicles exist today, kind of beyond the data that we have right now, and then where like the time period in which people anticipate they will transition those vehicles. And then like to the question that I just answered, I think continued visibility about where residential adoption is occurring could help us make that modeling a lot better as well. All right, let's go, so many questions. Let's go over here on the left, Brian.
Yeah, why don't we do one more here, and then we should probably do a couple online if we have time left.
Hi, good afternoon. Corey Johnston from Strider Technologies. This question is in relation to the security side of it, right? It's always a balance. You want innovation fast outpacing. But as you look towards fleets like ambulances, first responder vehicles, and then the vehicle grid integration, is there a consideration on the endpoint and the network grid cyber security side of the house? Is that something that you're working into your calculus?
Yeah, definitely when it comes to like the vehicle grid integration piece, or even just like communications out to like all of these different vehicles that are going to be connecting to the grid, I would say in no way do we have it solved, but it's absolutely something that like we're working with our internal teams on. And if there are ideas that you all have or things that you think can help us do this in a more secure fashion, that's definitely something that's of interest to us. Okay, let's do 1 or 2 more on the webcast.
Another question from the online audience. Have you evaluated the meter caller from Connect DER/Siemens? It supposedly helps to avoid panel upgrades.
Oh, we have. And I think I would just say if you guys read the R&D report, I think one of the things that we are very interested in is ways that we can leverage the socket, the meter socket, to avoid panel upgrades. And so I think please come with your ideas because that's something that we're very interested in finding. Like we know that that's a big barrier to customer electrification, and if there are ways to safely connect an electric vehicle, both for one-way charging and for bidirectional charging, that's something that we're really interested in learning more about.
Great. And I think we had, Chris, you had one more question?
Well, I can answer the first question if that's
okay.
What was the first question? The standards? Yes, go for it. Yeah.
Yeah, so for those online, we have Chris Morris from our grid team who's going to speak or address to that first question that we had online.
Hey, everyone. So at the megawatt scale, right now we are leveraging through our DERM system IEEE 2030.5 to allow for like dynamic hour by hour limits, which are forecasted the day ahead. So that would be for like a Electrify America or Tesla supercharging station. You get an hour by hour day ahead limit, and then there's also a real time if it gets exceeded, what you do in an emergency. So that's over the web, and that's in a pilot form right now. At the home level or kind of shared distribution transformer level, we don't have any standards for that yet. There are a few different ways we think we could do it, either on SEP 1.1, Matter over Wi-Fi, or kind of a host of other ways of doing it. But we are looking at starting a project to essentially expose in real time kind of the meters constraint. It's a bit trickier than just posting the amperage though, because those meters then all coordinate back to a service transformer, and we have to respect the service transformer limit. And then also in real time, we have to deliver within electric rule 2, which means we have to respect the voltage limit as well. So we're very aware that there's like amperage limiting devices that use CT clamps. Like that is not enough for us to deliver quality power to our customer. And so there's a little bit of work that we need to do, but we could really use input from the industry on like, what type of protocols do you want to see and how do you want to interface with us? But just know that it's more than amps. So.
Let's do one more question from the webcast.
Another question from online. How does PG&E intend to enable real-time communications for charging stations?
A couple of different ways. So we're working on, I would say it's not like, it's close to real time. So we're working on a day ahead hourly real time price rate, another mouthful in terms of the programs I like to put together. And that I think is going to be leveraging some platforms that the CEC is developing to basically send day ahead signals to our customers to let them know what the prices will be on a 24-hour basis. If we're looking at, I think, more real time, it probably is more similar to what Chris was just talking about, which is like the IEEE 20.5, leveraging our DERMS platform. But I think, again, that's an area where, like Chris mentioned, I think as you get closer to the transformer level, like the more input we can get from you guys on how we can communicate with chargers in a cyber secure fashion, those are really some of the big challenges that we are trying to work through today. All right, I think let's do one more question in the room, and then we'll probably have to wrap up and go to session number 2. Yeah, you want to go all the way back there or in here? That works.
Hello, Liam from Wallbox. My question is about, so the multifamily setup is obviously a lot more complex, and there's a few different electrical ecosystems that we see. One of the barriers that I think we come across often is how hands-off the HOA wants to be in terms of letting people do things like meter tapping, or if they want to go towards a centralized panel with all of the implications that has, right? So billing and shared energy. But ultimately that provides a lot more capacity in terms of energy management. Is this a concern for PG&E? People being hands-off and, let's say, not taking advantage of the opportunity to have the shared load management sites? And how can we address that, considering that a lot of the time after the decision is being made, we're a little bit too late?
Yeah, so I can provide a bit of a thought there, and then I'd be curious to hear what you guys have to say as well. So I think one of the biggest barriers to that is being able to get like metering, right? And like if you're a multi-unit dwelling site host and you need to bill customers, if you're using that shared infrastructure, it can be tough to have like an EV rate on those particular chargers and then a different rate to your building. And so we are actively working on deploying sub-metering, which would basically allow you to use the data from the chargers. So you could use then like shared panel, but then also meter those chargers separately without having to put in like a separate metering service. And so I think that is one thing that we're working on, because that also then enables more bidirectionality, right? If you have to build a separate service, then you're not able to then share the energy with like a building or a home. And so I think that can unlock a couple of different things, but it's right now very focused just on data from EV chargers. So like great opportunities for incorporating telematics, other forms of data, I think are some things that we're really interested in. And then again, I think like a lot of my answers to you all are like, yes, those are challenges, right? Like that is a challenge. And so if you guys have other solutions, like this is exactly what we're here for, like bring them to us and, you know, tell us what we should be thinking about that we're not thinking about today. Cool. Okay, I think we are at time. The next, oh, I thought we went to 1:45. Oh, just kidding. Questions for days. Who else wants to ask questions?
The gentleman with the white shirt way in the back held up his hand several times, so.
This patient man gets asked a question.
Hi. You guys announced what sounds like a very exciting DERMS collaboration with Schneider Electric earlier today. I'm curious how that fits into the solution set when it comes to addressing some of the challenges with EV integration.
Yes. So a couple of, I think it is incredibly important to addressing EV integration, right? It's kind of like the brains that will allow us to deploy a lot of these use cases. A couple of the things that were like the initial use cases that we're looking at are one, what we call flexible service connection. And so that's kind of right now more focused on like medium heavy duty fleets and DC fast charging. But we will say sometimes like a customer will come to us, say, I need to install 5 megawatts of chargers. And we say like, we don't have the capacity to do that. But realistically, we have the capacity like 98% of the year, and it's just a couple of hours a day on a couple of days a year, and like August and September, right, where we really actually don't have that capacity. So one thing we're looking at, and I think we'll probably talk to quite a bit more in the next session, is like, can we leverage this DERMS platform to then send signals to a customer to have basically a flexible interconnection. So you get that 5 megawatts 97% of the year, and then on those, you know, those couple of hours, we provide information about what the actual capacity is, and then the customer can kind of ramp up and down their charging based on that. So that's like one use case that we're looking at, but I think the being able to deploy DERMS and leverage it for a lot of different one-directional and bi-directional use cases will be super important. I don't know if, I feel like I've been dominating the answers here, but if you guys have any additional stuff.
Great answer. Yeah, no, nothing to add.
Thanks.
I'm going to go down here, and then we can go to the back.
Hi, Vaibhav Tunde from Lawrence Livermore International. So building upon the previous question, are you looking at electric vehicles as an asset for microgrids, B2G?
Yes, definitely. We have 3 bidirectional programs, or bidirectional pilots that we're launching or are launched: vehicle to home, vehicle to building, and vehicle to microgrid. And so we're looking at how we can leverage electric vehicles as assets in microgrids, and so bring those ideas and solutions. And then back here.
Hi there, Praneet from Tesla, and we obviously have a very relevant question here. For us, though, beyond just implementation and all this tech behind it, there's a big market demand question, right? People don't want to buy a Powerwall or an EV because of cost incentives, right? So what are you guys doing to spur, again, that growth to that 3 million, right? Because no matter what we invest in infrastructure, if people are not buying it, it's not going to work.
Yeah, I think a couple of different ways. I think like earlier on in like where we are in the market, right? I think there's continued opportunity both like for us in the state to provide incentives. So like an example is we just launched a pre-owned EV rebate program where customers who are looking to purchase a pre-owned EV can then get a rebate off of the purchase price of their vehicle, and it's even higher if they're certain income qualified customers. And so like I think there's opportunities now to kind of leverage incentives to drive down the price of both the charging infrastructure and the vehicles. But I think one thing, and we'll probably talk to this a lot more in the third session if you're interested, is like, are there ways, like if we're using electric vehicles as assets, right? Like if we are sending energy back to the grid, if we are managing charging around different times, that's creating value, right? That's providing value to the grid. It's creating probably like a GHG emissions reduction value if you're shifting it to the right times. And so how do we understand that value and then share that value with consumers to then help bring down the total cost of ownership for chargers and vehicles? And so those are all big questions that we're grappling with. Any thoughts that you all have on modeling to figure out like what is that pie? Any ideas you have on like business models to help split that pie, ways to do that more efficiently, like bring those all our way. Okay, let's do maybe one more on the webcast. and then we can come down to you.
Question from online. Do you consider VG1 or say do you consider VGI or say V2G while planning and designing the charging solutions for fleets, commercial, and residential customers?
Yes, I think that is exactly what we are trying to incorporate more and more of into our designs, into our thinking, into our long-term planning. I think like some of what we talked about here, right, with like the concept of how can we get more electric vehicles to charge at home while not having to upgrade as many transformers or as many panels. Like that is exactly, I would say, the way we want to be thinking. It's probably not how we historically have thought.
Yeah.
And so like that is exactly like the shift that we're trying to make here, both on the residential side and on the non-residential side, as we do planning, as we develop processes, as we think about technology that can help us make that shift and plan the grid in a way that is considering both like the infrastructure needed, but also the flexibility that EVs can provide to kind of optimize that grid build out and optimize the ability to leverage these vehicles as assets.
Yes.
Great. I'm going to put a stop right there. I know we're over time, so I just want to make sure that everyone has time between the sessions. Any closing remarks for anyone?
I think, let's see, a couple of things. So I think we answered the one follow-up question, but I mean, you guys have time to move between sessions, but there are folks here that if you have like further clarifying questions you want to talk to, feel free to ask some questions as you're transitioning. And then like, I think the theme of today is like, we're all ears. Like reach out, share your ideas, ask your questions, like dig into these challenges with us, because our goal is to work collaboratively to really solve a lot of these challenges.
And I'd like to just say thank you so much for your time. We really appreciate your attention and that being willing to have that brainstorming thinking, being willing to really help us move the needle to move California into our electrification goals. And I know that we can do this together. And I just thank you all. I'm available. We'll be out in the lobby if you have any questions for service planning and design. Happy to give you anything you need and give you my contact information if you need that as well. Thank you and have a wonderful day.
Thank you.